Hello and good day, Algebra. We are talking about CO56, which is essentially the opposite of PO55. In PO55, I gave you a quadratic equation, and I asked you to find the x-intercepts of that parabola. In 56, I'm giving you the x-intercepts, and I want you to write me the equation of the parabola. How dare I? How dare you? Okay, so let's kind of look at the example here. I start by going over just review on how to factor something, which we just corrected or just went over PO55. So this process should be pretty familiar. But where we're starting today is with the x-intercepts. And so if you know the procedure to factor something, then getting back to the equation is really just the opposite. If I tell you that the x-intercepts are -7 and -8, then what would our parentheses have looked like after factoring? That would have given us x-intercepts of -7 and -8. Well, one set of parentheses would have been x plus 7. That's where the -7 would have come from. And the other set would have been x plus 8. That's where the -8 would have come from. And from here, from our two sets of parentheses, what's our method to get back to the original equation? From our two binomials, x plus 7 and x plus 8, what's our method to get back to the original quadratic equation? Julia? Using what method? Crab claw or box or foil, all those glorious things we learned back in PO45. Okay? So really the only new part of CO56 is going from the x-intercepts to our binomials, from the x-intercepts to our parentheses, because once you get there, it's foil, crab claw, box. Right? So let's look at x equals 4 and x equals 7. What would our parentheses had to have been to get an x-intercept of 4 and to get an x-intercept of 7? Brent? X minus 4 and x minus 7. Because remember, the 4 and the 7 are the numbers that would make these parentheses equal to 0. Okay, that's why it's a -4 and a -7. And once we're here, foil, crab claw, box it, whatever you want to do, you'll end up with x squared minus 11x plus 28. And there's your original equation of the parabola. Epic, indeed. So these first few objectives of this unit have all been kind of, what do parabolas look like? What are their features? What are their characteristics? How do we use these things? How we can use the x-intercepts. If you know the x-intercepts of a parabola, you can get back to the original equation by foiling, crab clawing, boxing, once you get them in the parentheses. Hummy McHummerton, whoever that is. Shush. Okay. Let's look at the next one. It's a little bit, I won't say it's more complicated, but when you've got fractions here, you need to remember where those parts of the fractions came from. So for our two sets of parentheses, what would have been the expression in this first set that would give us positive 3/4 as an x-intercept? Erica. Not 3x minus 4. Getting closer. Wait, what did you say? 4x minus 3, yeah. 4x minus 3. Right? That numerator of our x-intercept is the opposite of our constant. So if the numerator is a positive 3, it means our constant in the parentheses would have been a -3. And then that the denominator is the coefficient. So if our x-intercept is -9/4, the original expression would have been, Noah? For the second one? Yes. Oh, 4x minus 9. Sorry, the second expression. plus 9. All right. Since it's negative, that means the constant would have been positive in the parentheses, and then a denominator of 4. That 4 represents the coefficient. And then boxing, foiling, crab clawing, whatever you want to do here, 16x squared plus 24x minus 27 is your original equation. Okay, what's that? Okay. The last one here. Knowing that one x-intercept is 0, what form is our equation going to end up being here? With one x-intercept being 0, what form is our quadratic equation going to be? Brent?
ax squared plus bx.
Right, ax squared plus bx. That x-intercept of 0, that's that freebie one, right? So this one is going to be represented by just an x outside of our parentheses. And this one, what expression inside of our parentheses would give us an x-intercept of negative 10? I heard it. What? X plus 10. Okay. X plus 10. Which, when we distribute the x into our parentheses, gives us x squared plus 10x as an original equation. Okay. Questions thus far? Soybe.
For the fraction, did you always use the denominator?
The denominator is always going to be your coefficient. Yes. Yep. And then that numerator, the opposite of that number is what your constant will be. So let's look at some on the practice page here, and just one page of practice, I do believe. Which one looks particularly fun? What would you like to do together here? Any of them stand out? Noah? The last one. The what?
The third row, I meant.
Like the whole row you want to do?
The whole row on the last one, yeah.
What?
The whole row on the left. You make it
No, the last.
Negative 3/10 and negative 1/4?
Sure.
Okay. X equals negative 3/10 and x equals negative 1/4. So these are the x-intercepts. And so what we got to be thinking about is what expression would give us negative 3/10 as an x-intercept. We look at our denominator, and we recognize that is going to be the coefficient to x in our expression. And then we look at the numerator, and we're going to take that negative sign and kind of assign it to the numerator. Negative 3, the opposite of that is positive 3. And so 10x plus 3 is the expression. Then for negative 1/4, again, the denominator is our coefficient to x. Our numerator being a negative 1 in our expression means it's a positive 1. What's that?
You have two different values for ax.
I mean, two different values for ax.
Like, you have 10x plus 3 and you have 4x minus 4.
Right. Yes, because this isn't our final equation in standard form. This is the factored form of whatever our equation was, which is why we now have to foil, crab claw, or box this to get our final equation, which if you do that is 40x squared plus 24x plus 3. And that is your final answer. Whoa. Okay. That's it. Yeah, it's not really anything new per se. It's just how do we use what we've learned to do stuff with it, right? How do we know how do we use this to do stuff? Okay. Where this comes in handy, so with my real life examples before. Some of you told me that you don't plan on measuring home runs when you grow up, so you don't care about that. You don't plan on making bird baths or satellite dishes. You don't care about that. But if you're going to be a bridge builder, who knows? And you've got to build a bridge over a dangerous ravine, and you know that the bridge has to start here and end here. You can use those x-intercepts to make the equation. Do you want your bridge to be, fairly wide? Do you want it to be, a little more narrow? How do you want it to look? And by knowing the x-intercepts, you can develop equations that are going to make, because the last thing you want to do is start building a bridge and then have it come up short. That's not going to be good for anybody, right? So that's kind of some of the applications, very simplistic version, but applications of what we are doing here. So any questions, comments, concerns, complaints, comments, congratulations, or criticisms on CO56 or anything else?
Good job.
Yes, you need to do all of it, but it's due Tuesday, so calm down. Soybe,
Congratulations.
on what?
You did a really good job.
Thank you.
Showing us that bridge building uses this.
Thank you. Couple other reminders. I said con is due tonight. Don't forget about that. Your memory book is due on Friday, as well as your most likely to pages. Please get those things done. Otherwise, you'll be forgotten. Well, if there are no memories of you, I mean, that'd be no. All right, folks. That's all. That's how you math.